Well, how are you doing? Okay, this video is going to be about how a globe's refracted horizon can never work with the dip and height of eye corrections. As you can see on screen here, I have a red arrow, I have a yacht here and a red arrow here, probably about 15, 20 feet of a height of eye correction here you would make with a sextant. I have height of eye is dip. See, these two things have been since they added globe into celestial navigation back in the late 1800s, early 1900s. Since they started adding in globe into it, they started separating height of eye and dip. You see, the height of eye is measured from the observer's eye height standing on the boat they're on above the water. So let's just say 15, 20 feet is the height of eye for this boat here, right? So the observer will be standing about here, and this would be the water. Now, this is measured at port, right? So the measurement of the height of eye, also known as dip, is measured at port. So they know when they leave port, they measure it in the calmest water they can find at port. So they know when they leave port, the navigator knows, regardless of the size of the boat or ship, the navigator knows the amount of dip that they will need to correct for. So every time they take an elevation angle measurement, they know the amount of dip to correct for. They know the amount of height of eye to correct for. They don't have to change that. They know based on the height of their eye above the water below the boat. As I said, this is done at port before they leave. So if you're on this boat sailing for 5-6 weeks, and you are doing 2 sextant observations a day, or you're using the sextant on board twice a day, and you are looking to be as precise as possible, you're going to use it properly and to be precise and to not be way out on your final measurements of distance, you're going to have to include height of eye. So let's say this is 15 or 20 feet off of the water, then there'll be a couple of minutes of degree or whatever. The charts are there in the nautical almanac to see the amount of dip for 15, 20 feet. Doesn't matter what it is. The point is, they would know that that is the amount that they need to correct for. So they don't have to measure a dip they're not measuring the depression angle from the right to the horizon all the time. They measure between the horizon and the celestial body, and then they do height of eye correction, which is dip. Same exact thing. The two of them are the same. But they've tried to mathematically mess around with these two things when they're trying to force globe into celestial navigation. And that's when it becomes a problem. So you have observer's eye line and you have surface of water, right? So I'm just going to get give me an arrow, right? So the dip is going to be, right, from there, let's say that's the horizon, there to there. That's going to be the dip, right? So the height of eye is going to be the correction of the height of this observer's eye down to the sea level, making horizontal. That's how it works, okay? Because the adjacent has to be horizontal, right? But the dip, right, is height of eye. So the dip to the horizon, right, the sea horizon, will be just the height of eye correction. That's all it will be. There isn't any two corrections necessary. There's no need for that. They have the measurement from port, and they just use that every time. So every time they do a measurement, they just use the couple of minutes or whatever it is of degree, or even minutes and seconds, whatever it is, that corrects their eye line down to the water. That's what they do. All right. They don't do two different things, but they want the people who force the globe want people to believe they're doing two different things. So let's bring this back down. And I'm just going to go to, right, here we have Metabunk, right? This is just a screenshot from Metabunk, so it's not actually Metabunk, but it's the screenshot from what they show. So here is the horizon that they're trying to claim is there, right? But here, if I'm just going to get tools, annotate, sorry, and arrow. So This is where they're claiming the horizon is, right? Being here and here. But this is eye level, right? Level being horizontal, right? Not with the not level, not being as Metabunk prove, and I've pointed out in the past, not being equidistant from the center of a sphere. Eye level is the horizontal line from the eye, right? That's eye level. And then you have surface level. Could also call it sea level, mean sea level. Okay, another horizontal. So eye line and surface level make a parallel with each other. But Metabunk wants you to believe that this green line is some kind of a dip angle between an observer's eye line and some kind of a geometric horizon. But there is no dip, right? It's from the eye line, eye level, eye horizontal, right, level, down to the surface horizontal level, right? That's the dip. There is no geometric globe's horizon that you need to correct for. It's total nonsense. But this is all that happens, a correction from eye level to surface level, right? Now, you'll see why I'm being so pedantic about this soon. So now we go to, now, this is from the Davis Sextant Manual, right? So as you can see here, they're showing a dip and height of eye correction, right? Now, why are they showing a dip and height of eye correction? There's no need for two corrections. This is your horizon out here, right? You're not correcting up to an horizon from an horizon you can't see. You're not correcting from something you can't see under the water up to the horizon and then correcting for your eye height of eye down. You're just correcting for height of eye to the horizon, right? So, let's get the other one, right? So, you have, this is your, right, this is the observer zenith is up here, right? This is the zenith from the GP to the star. You just have an obtuse angle, right? And you correct it down. That's all you do. That's your correction. You're correcting for height of eye. This dip thing is a load of nonsense because all they're trying to make you believe there is that you're correcting, one second now, let's get it together, from this point, from an eye line to an horizon, right, a geometric horizon that doesn't exist, up to here, and then you're correcting that down. So that line is the same as the line behind it, right? That's what they want to make you believe, right? But you're not. You're just correcting from the eye line to here. It's just height of eye. It's a dip, right? It just will be a dip when it's at the eye line, right? There's the dip angle, right? It's an acute angle. This is an obtuse angle. So you're just correcting for the height of eye down. That's all the dip is, right? Now, as I said, why I'm being so pedantic, excuse me, will come clear in a while. I'm just going to show some more. So, right there you have true horizon at sea level. You have oil. This is from another official source, probably from a book or whatever. So it's the diagram's not brilliant, but I show it because it comes from that. You have oil line to this what they call an apparent horizon. Then you have true horizon. But true horizon is at the bottom of the boat where the water is. So this apparent horizon is total nonsense. It doesn't exist. So you only have true horizons. You just have dip from here to there. That's all you have. So you have, right, once again, dip from here to there. That's what you got. That's all you have, right? There's no dip down to this geometric location that doesn't exist. Here we have it again, right? Try and make this a bit bigger. So you have, this is observer's eye line, right? This is their angle line to the star. This is the dip to what they're calling a visible horizon, but this is sea level here, 0, right? This is a 0 degrees horizontal, right? Now I know this is observer, but the point I'm making is this here, so I'm not confusing the O with 0. This line here, this is sea level. So they're correcting, right, the obtuse angle that would be going from sorry, from here to there, right? They're correcting for that, which gives them then, right? Once they have that, they then have that. They're correcting for that. That's what they're correcting for. They're not correcting for some dip down to this thing that doesn't exist. They're not doing that. But they want to make you believe, people who have a heliocentric belief want to make you believe that. But I'm going to show you in a while where their heliocentric belief makes that impossible. Once again, right? Observer, right? Right? As you can see, the height, observer's height of y, right? This is from the Maritime SA, I think it's South Africa, www.maritimesa.org. Here they're trying to, again, come up with some dip down to here that doesn't exist. There is no dip down to anything. So once again, right, you have this dipping to there. That's the horizon. That's the eye line, the observer's, right, eye line level, right, observer's eye level. And this is the observer's, this is underneath at the water, this is the surface level. So all you're doing is correcting them for there, down to there, right? And you're correcting down horizontal, and that gives you that. So it's just this angle here being brought down to there. That's the height of eye correction, also known as dip correction. You're not correcting for this nonsense here. This is total and utter total rubbish, super rubbish. Nobody's doing that. You can't see this geometric location. Officially, it can't be seen. It can't be seen, it can't be accounted for, and it can't be in reality, and it can't be measured in reality. None of that happens. It's purely only between here and the eye line, right? And you correct down to there, right? There's your horizontal, there's your angle line to the celestial body. Now, I'm going to show you why what they claim, even though they're trying to add in some kind of a geometric horizon there, why it's absolutely impossible, right? Oh, sorry, one more to show. Just so, right? Same thing again, right? Ship, there is the sea level at the bottom, and they're trying to claim you're correcting up the sea level. How can you correct up the sea level? How can you correct up the sea level? That's total nonsense. Sea level is 0. You're correcting down to sea level. That's what you're doing. But they want to make you believe that this is refraction, right? This is not celestial refraction. Celestial refraction is about temperature and pressure, and it's about any celestial body below 15 degrees off of the horizon and its apparent position. So its apparent position will be different with the refraction in accordance to the horizon or with respect to the horizon. But the horizon won't be different. The horizon doesn't be different. It doesn't go up and down. The horizon moves away from you further and comes closer to you. It doesn't go up and down, up and down. That's why they can use it, because it doesn't go up and down. It is at sea, the sea horizon is a constant. That's why they use it, and they can use it with a marine sextant, because when you use it with a marine sextant, it's the one place that is steady at sea. When you're at sea, you can't get your zenith because you can't be steady. You have to correct, right, your dip. One more time. I know this is probably a little bit pedantic, as I said, but this is arrow, right? Right, don't mind that. I won't bother. So it's just some issues because I have this already. So you're not only correcting down to this horizontal. You're not correcting down to this curved line here. You're correcting down to this horizontal, right? That's what you're doing. You're not correcting to a dip you can't see, to a position you can't see. You're not doing that. They want you to make you believe that you're correcting down to this, and this is somehow refraction when you're going from here up to here. That's not celestial refraction. It's about the position of the celestial body in accordance to the horizon below it. The horizon is not the thing that's being refracted. It's the celestial body that's being refracted. So they can make claims of the opposite happening, but I'm going to show you now why those claims are complete and utter nonsense. Now, this is going to show you why their claims are complete and utter nonsense and a complete impossibility. Where is GeoGebra? Okay. Here is a green circle, right? That is the exact size of the globe Earth, right? The claimed globe Earth. That's its exact size. 3959 statute mile radius. The orange circle surrounding it is the refracted 7 over 6 R, right? Constant, right? That we're told we see. We're told that there's a constant of at least 7 over 6 R, right? And greater than 7 over 6 R. So what that means is that their globe, right, to straighten out their globe, they have to increase the globe in size. Do you understand? So when they need to deal with an observation like with the black swan, right? Instead of that green circle being their actual globe, they always need to claim that their globe that is presenting itself like this orange circle, at least that size, right? Which has a radius of 4,618.83 statute miles, as opposed to 3,995 statute miles. So they need to increase the radius, right? And they say you will never see this green circle. You can only ever. They claim that you can even actually maybe see this orange circle size. It's complete and utter nonsense. But what they do is they try and claim that the horizon is changing. It's not just going out further from you and coming back closer to you, but it's actually going up and down. And I'll show you in a minute. So for the black swan observation, and there was a great, and even the person who took the black swan observation, BLMSB 69, got an even greater observation from the same height of, I think it was 28 or 31 miles, not 10 miles. So for just the 10-mile observation of the black swan, the globe Earth needs to be this size. That's the size the globe Earth needs to be, right? So that tells you there's a massive increase in the size of their globe to try and explain away what we see in reality. Because they need to straighten out their globe as much as possible. What this would mean is there'd be a small little 5% of this up here that would cover the whole span of their globe's circumference. And the rest is just made up in belief, right? That's how it works. But all that, right, is the killer for them. And this is why none of this nonsense will ever work with celestial navigation, especially with a marine sextant. And this is the reason. So I'm going to come in here now. I know I had to zoom out a bit, just coming into a little walk around that here. So here we have, similar to what it shows in those diagrams, right? Here we have, they say this is the observer. This is sea level below them, right? This is their dip to the supposed geometric horizon, right? Or sorry, refracted horizon, right? We're told we'll never see the geometry of the globe. So what happens when they need to take the dip? Now, as I said earlier, just before I go further, as I said earlier, dip and height of eye are the same thing. Now, they've tried to separate them to add in a globe, but in reality, they're the same thing. This height of eye above the water will be the correction. The dip correction and height of eye correction will be exactly the same, because it's the same correction, every single time the person who's on this boat uses a sextant. So they'll only be correcting for the height of eye above the water below the boat. That is the dip correction, right? Right? What they're trying to make you believe is that the dip correction is a different correction that happens before height of eye. But the dip correction, if you look into the dip tables, right, there is a consistency with the dip tables. So 15-20 feet will give you you will have a certain dip for 15-20 feet of correction, right? A certain dip. So the person on this boat using a sextant is going to be using a sextant. They'll have a dip to the horizon because the eye line is above the horizon, because their eye level and sea level are two parallel horizontals. So consequently, what will happen is every single time they'll use the exact same dip correction. They can't measure it other than that. Their only measurement for dip, their only measurement of dip is their height of eye correction above the water. They don't have a second measurement. There is no other way to measure it. That is their measurement, the height of eye above the water. So when they do that correction, right, they'll be doing the same correction every time. If you look at the globe, they're trying to claim, right, that the height of eye correction and dip correction are different, right, these people. But what that means is this. That means that their refracted globe, because it's consistently refracted, that's their claim, right? That's going to be changing all the time, up and down. That's what they're trying to claim is happening, right? That's how they try to explain the black swan, right, and other observations of to the horizon. There's this Melosian, an accordion horizon going on, right? The globe is going up and down, up and down. That means every time that this person comes to on that boat comes to do the dip correction, they're going to be doing the dip correction for the exact same height of eye above the water. But if the dip correction and height of eye correction is determined, like if we go by what they're trying to claim with the globe, that would mean that their refracted horizon would be moving up and down, which would mean that, let's just say they did a dip correction right now, right, which would be height of eye correction, right, and then they go to do a second measurement, and this has happened in between those times, or a bit later, and they're using the same exact amount of dip correction. What happens? You're going to be all out. You're going to be wildly out. You'll have no, besides the fact that you can't do any of this on a curved surface. That's not the point of this video, though. The point is that, even though it obviously is a very valid point, the point is that with their moving horizon, their Melosian box, accordion horizon going up and down, right, with that happening all the time, then in the morning or in the evening, they could take a sight, right, of a celestial body, or during the day with the sun or whatever, and then later on in the night, their dip correction will be the same every time, because it's based on their height of eye above the water. So that's never going to change. So if that's never going to change, but the horizon is changing its position up and down, then that means their dip, when the correction they make, will put all their measurements wrong. And they'll constantly be wrong. It would be impossible to ever, besides the fact you can't do it on a curved surface, it would be impossible to ever if you just take just the horizon there, or refracted horizon into account, it would be impossible to ever have consistency. You would never have any measurements correct. You'd always be widely out. So when you're making your 3 circles of equal latitude, which can't go onto a globe because they're not circles, and the globe will be too small because it's got a limited size and surface area. The point is that none of it can happen because it's all going to be wildly out. None of it would work, because if you've got an horizon dip that's changing, and the person on the boat only has their height of eye correction for the dip, then every time they can only do that correction. They can't measure it any other way. They can't measure it off their horizontal. The whole point of the height of eye correction is to create the horizontal. So they're trying to create the horizontal based on their height of eye above the water. That is dip. But what they try to do is give you the impression that there's a dip correction from something you can't see, that we're told we never see, which is a geometric globe's horizon, up to water level. But if that was the case, then what they're accounting for, their dip, they could never measure that dip. So all they can do is use the height of eye. The dip based on the height of eye, that's all they can do. And that's going to be the same every time. But if the horizon is not the same, in the same position, let's say if it's down or it's up at 2 different times, then your dip and height of eye is going to be all wrong. You're never going to be right. You're never going to be right. So consequently, there is no dip to a refracted horizon, because the claim of a refracted horizon would ruin the dip. Whereas only height of eye above the water, and that gives you your horizontal on the water, all the way out to the horizon and on for whatever the measurement is. So if you get a 40-degree elevation angle, that'll give you 50-degree zenith angle. 50 by 60 will give you your zenith distance between your horizontal distance along the surface of the water, using mean sea level, between the zenith of the observer and the zenith from the GP point. So it's 2 verticals and a horizontal distance between them, and that's what you're doing. You're not using any refracted globe's horizon. You're not using any dip to any globe horizon. There is no globe horizon. It doesn't exist. The horizon is an optical location and not a physical location. And it's not a refracted position either. It's an optical but not refracted, right? The horizon is constant, and that's why when they do height of eye correction, they're also doing dip correction, and it works every single time ever, because the dip is the water where the horizon is will be the same elevation as where the height of eye will bring the eye line. So When the dip to the horizon that this navigator on this boat sees, when they do the height of height correction, they'll be bringing their eye line down to the water, and where the horizon is will be in a direct horizontal from this point, and on and on and on. So, so if you had a 50 degree zenith angle, you'd have like around, was it 3,000 mile nautical mile horizontal distance. So you only have height of eye. This thing about dip and then height of eye, no, you only have height of eye. And every time height of eye has to be the same. So if your dip was different every time, so if your dip was changing around, right, your height of eye would never be correct. Because you can only correct for your height of eye. So your height of eye is going to be thrown out if your dip is thrown out. You can never use a globe. That's the point. You can only, you always have to keep coming back to a horizontal plane. Because that's reality. You can't use this. You can't do any of this. It doesn't work. That's the point. So the claim of a refracted horizon going up and down, because that's what they're claiming when they're claiming anything to do with 7/6 and greater than 7/6, or they're claiming this. That's what they're claiming, which would change dramatically the position of the horizon. So the horizon couldn't be used as a horizontal straight out from the water underneath the boat. Couldn't use it then like that, because you don't know where it's not. You won't have a horizontal. You'll never have a horizontal. You might make a straight line somewhere, right? Somehow, but you won't make a horizontal. You won't make perpendicular. So, and even at that, you won't have a straight line because you'll always have a curved line. It's just going to be a disaster, or it'll be a chord maybe. Or it's a tangent. It's going to be just an absolute disaster. It could never work, and that's why celestial navigation is only ever done on a horizontal plane. Thank you.